So in this example, we're going to be looking at integration by parts again. Now, you may have seen in a previous video or in your lectures or in the textbook, there's a formula that you can use to do integration by parts, and it's something of the form uv minus the integral of v du by dx. If you were to apply that method here, you'd actually end up integrating by parts 3 times. And that's okay, there's not a problem with doing that. It's just going to take you quite a while to do, and chances are you might make an algebraic slip, you might miss a minus sign. So there's more scope for error doing it that way. What I wanted to show you was a different way of setting out integration by parts. It's still the same method, but you're just setting it out in a different way. And I like to call it the ID method. So what we do, we set up 2 columns, I and D, where I stands for integrate and D stands for differentiate. So basically we just need to choose one function to integrate and one function to differentiate. As mentioned in a previous video, you have your lie8, which tells you which function you should differentiate. So let's just do a quick reminder of that. L stands for logs, so if you have a log in your expression that you're integrating, that should be the one you differentiate. I is inverse trig, so if you have an inverse trig expression, that should be the next one that you differentiate. Then anything algebraic, so powers of x. T is for trig, and final one is for exponential. So let's have a look at what we have here. We have an algebraic term and an exponential term. Well, algebraic term appears before the exponential term in our lie8, so that tells us that should be the one we differentiate. So I'm going to differentiate x cubed, so I'm going to put that under the D. So x cubed. So that means it must be the e to the x that I'm integrating. Now, all the ID method tells us is to differentiate as many times as we wish. Typically, though, we want to differentiate until we get to 0. Now, not every example will end up going to 0, but most of the cases it will. So let's have a look at differentiating this until we get down to 0. So you differentiate the first time, we'll get 3x squared. It's not 0, so I'll carry on differentiating. 3x squared differentiates to give us 6x. Still not 0, so I need to differentiate again. So differentiate 6x, I get 6. And we're almost there. Differentiate 6, I get 0. So you can see we've differentiated 1, 2, 3, 4 times. So the number of times I differentiate, I need to integrate the same number of times. So I need to integrate e to the x 4 times. Now this is a nice example because the function e to the x, when we integrate it, just becomes e to the x. So I can just fill in e to the x for each integral. You might not know it, but we're actually almost done. You can almost write down our answer. The ID method tells us to draw a line from the second term up to the first term in the D column. Then the third term up to the second term, fourth term up to the third, fifth up to the fourth, and then there's a line that goes across at the end. And then what we have is a series of plus, minus, plus, minus, plus signs, and I'll show you where they come in a second. And that's almost our answer done. We can now write down the integral of x cubed e to the x is given by e to the x times x cubed. So these arrows actually represent multiplication. So it's e to the x times x cubed times by plus 1. So that would be x cubed e to the x. The next one is e to the x times 3x squared times by minus 1. So that will give me minus 3x squared e to the x. Next one, we have e to the x times 6x times plus 1. That'll give us a plus 6x e to the x. Then we have e to the x times 6 times minus 1. So that'll give us minus 6 e to the x. And then for the horizontal arrow, that actually represents the integral. So it's actually plus the integral of 0 times e to the x. But we know the integral of 0 will just go away, and we have our plus c on the end. So actually, that's our answer. We can, if we like, pull out an e to the x from these terms here, so that's what we'll do. We'll factorise that out to leave us with an x cubed minus 3x squared plus a 6x, a minus 6, close that bracket, and don't forget our plus c at the end, our constant of integration. So hopefully you can see that this ID method has very much simplified your integration by parts. It works exactly the same, it's just a different way of laying it out. Thank you for watching.